Welcome to the Bentley Systems training course where you will learn how to model loads and generate load combinations in STAAD.Pro Connect Edition. In this video, we're going to be focusing on the process for creating reference loads. We will now turn our attention to our sample model. Now for this model, we're going to be modeling some reference loads. So to begin this process, we're going to select the loading page within the workflow page control area. Once we get the load and definition dialog, I'm going to expand my load case details section and also my load case details. Now within the definitions area, I'm going to find a reference load definition option. Now within this reference load definition, I can create a few reference load cases. So let's start with that process. Up in the ribbon toolbar, I'm now going to select the reference load case icon. As an alternative method, you could also create these load cases by highlighting reference load definition and then clicking on the add button down here. So I'm going to create a reference load definition. I'm going to call it reference dead load, and I'm going to set the loading type equal to none for this exercise. Once we're done, we'll go ahead and click the add button and then click close. Now within this reference load case, I can add any different types of load items, which are basically very similar to the process for adding load items within any other primary load case. There is a major difference between a primary load case and a reference load case, however. A reference load case is solved only when it is later called upon in a primary load case. The benefit to a reference load case is that it enables you to define as many load cases that you wish, but it instructs the program to actually solve only a limited number of real load cases, thus limiting the amount of results to be examined. Now, reference load cases can be used in a variety of different areas in the program. You can include them in a primary load case. We can also include them in a seismic definition or as part of a mass definition for a dynamic seismic analysis. For this exercise, we're going to go ahead and define a few basic load cases within this load item, within this reference load case. Then we're going to call them upon later on in a primary load case and also within our seismic definition. So to start this process, we need to add load items within this load case. So I'm going to highlight my reference dead load. Then I'm going to come down here and click on the add button. And here you can see all the different reference load items that I can add. For my particular model, I'm going to add some self-weight. So I'm going to highlight the self-weight option. I'm going to tell the program I want it in the Y direction, which is my vertical axis, with a factor of -1. Once I'm done here, I'll go ahead and click on the add button. And I'm, in addition to that, going to add some member loads here. So I'm going to select the uniform force option. I'm going to enter a force of -0.05 kips per foot in the global Y direction. And then we'll click the add button and click close. Now the process here again is the same as if you were assigning load items within a primary load case. I'm going to notice over here I need to assign them to the model. So I'm going to highlight my self-weight option here. I'm going to say assign to view, and then we'll click the assign button. And in addition to that, for my uniform loads, I'm going to assign these to all the beams in my structure. So I'm going to highlight the load, unselect everything, and we'll go to our select ribbon toolbar option. And I'm going to find parallel to the global Z axis. And then I'm going to finish this off and assign that to the selected members. Now, what am I going to do with these loads after I create them? Well, again, this load case is not going to be directly analyzed by the program. I have a few options here. Again, I could include it in a seismic definition if these were defining my mass of my structure. I could use a reference load case for a time history or a response spectrum analysis. I could use it in any other primary load case, and I can also include this in a repeat style load combination if I had assigned it a load type. For this exercise, let's go ahead and add it to our seismic definition and then wrap it also into our dead load case. So I'm going to highlight my seismic definition, and we'll go ahead and click the add button. You can see my seismic definition has already been started. So I already defined all of my code parameters, such as my code I'm using for seismic definition, my response modification factor, my importance factor, all that's already been defined. I have not defined my seismic mass yet though. So I'm going to use this load case to identify that. So I'm going to grab my reference load here, and here's my dead load of my structure. So I'm going to pull it over. Now, typically when we define seismic weights, that we usually enter them with a positive value because it represents basically a directionless magnitude of dynamically active weight. So since I gave these negative values up here, I'm going to tell the program I'm going to kind of take the opposite of that. So I'll go ahead and include that. We'll click the add button, and then we'll click close. So here's a unique way of where I can use that reference load case somewhere else. And if I go down here to my load case details, let's highlight my dead load item. And again, we'll click on our add button. And here we can grab our reference loads as well. This time I won't change the factor. I'm just going to use it as is. So we'll go ahead and click the add button, and then we'll click close. So here you can see how I can use those reference loads. Now again, reference loads can be used for a variety of different reasons. It'll also allow you to add additional load cases to your model so that they're stored within your model but not directly analyzed. So it will save you some analysis time if there's information you want added but not necessarily analyzed for that particular run.